Welcome to The Explainer. Today, we're going to uncover something pretty amazing. How a simple, messy problem, like a flooded river, actually gave birth to one of the most powerful and, honestly, beautiful logical systems ever created.
All right, so let's dive right in. And we're not starting with some abstract math problem. Nope. We're starting with a super practical issue from thousands of years ago. Because, believe it or not, the entire story of pure logic, it really begins with mud.
You know, the word geometry itself kind of gives the game away. It literally means earth measurement, and that is exactly where it all started. It wasn't about fancy theories, it was a set of practical tools you absolutely needed to build the first great civilizations. So you've got ancient civilizations all over the world, from India to Egypt, becoming these masters of practical geometry. And they weren't just building things for the sake of it. They were creating order out of total chaos. I mean, just try to picture this. You're in ancient Egypt. Every single year, the Nile floods, and poof, all the property lines are just gone, washed away. Geometry for them wasn't some boring school subject. It was a flat-out survival tool. Yeah, all this knowledge was born from pure necessity, right? You needed geometry to build the pyramids, to figure out how much grain you could store in a silo, or even to make sure your bricks were all the right size. But here's the thing. All this knowledge was basically a collection of recipes, a bunch of how-to guides passed down by word of mouth or written on palm leaves. It was incredibly powerful for sure, but it wasn't a system. And that brings us to the crucial point. They knew how everything worked. I mean, their results were just incredible. But nobody was really asking why. Why are these rules always true? They just had a set of instructions that got the job done, and hey, for a long time, that was totally fine. But then, everything changes. A huge, monumental shift in thinking happens. And it's all thanks to the ancient Greeks, who got completely obsessed with a new, and I mean truly revolutionary question. Why? So this one mathematician, Thales, is a guy who gets the credit for the first known proof. And what he proved wasn't super complicated, but the idea behind it was profound. He laid out this logical, step-by-step argument showing that a circle is always cut into two perfect halves by its diameter. See the difference? He wasn't just saying, hey, this is a fact. He was demonstrating why it had to be true. And this shift, wow, it was a total game changer. It's like the difference between just following a recipe and actually understanding the chemistry of why it works. The focus was no longer just on the how. Now it was all about the why. Okay, so this new obsession with asking why is what sets the stage for one of the most influential books, well, ever. A book that would literally shape how we think about logic and reason for thousands of years to come. So, around 300 BCE, this teacher in Alexandria named Euclid decides to take on this absolutely monumental task. He gathers up centuries of scattered geometric knowledge, all the work from people like Thales and Pythagoras, and he decides to organize it all. And the result? His masterpiece, The Elements. Now, what's really important to get here is that Euclid's genius wasn't just about discovering a bunch of new theorems. Nah, his real brilliance was in taking everything people already knew and arranging it into this single, elegant, perfectly logical system, all built up from the simplest possible starting points. So how on earth did he do it? How do you even begin to build an entire field of knowledge from the ground up? Well, he started by defining the absolute basics, but that very first step, it led him straight into a really fascinating logical puzzle. He kicks things off with 23 definitions, and the very first one is for a point. He says a point is that which has no part. I mean, it sounds simple, right? Almost kind of poetic, but that one little sentence is hiding a super tricky logical trap. Just think about it for a second. If you defined a point with the word part, then to be really rigorous, you got to define part, right? And whatever definition you use for part is going to use other words, which you'll then have to define. You can see how you'd get stuck in this endless chain, this infinite loop of definitions. The solution was, well, it was kind of radical. To break that infinite chain, they decided to just stop, to just accept that some core ideas have to be left undefined. So things like point, line, plane, those became the fundamental starting blocks. We all intuitively get what they are, even if we can't nail down a perfect definition using other words. Okay, so once he had his definitions and these undefined terms sorted out, Euclid laid out his starting assumptions, and he split them into two groups. First, you've got axioms, which he also called common notions, and second, you've got postulates.
The axioms were meant to be these super obvious, universal truths that apply to, well, everything, not just geometry. Like his famous one, the whole is greater than the part. I mean, that's just self-evidently true, right? Doesn't matter if you're talking about a pizza or a line segment, it just is.
Or how about this one? Things which are equal to the same thing are equal to one another. This is literally the bedrock of the logical reasoning we all use every single day, most of the time without even realizing we're doing it. Now, the postulates, those were different. They were the specific starting rules just for the game of geometry. And the first four are so simple and intuitive, you just have to nod along. You can draw a line between any 2 points. Check. You can extend a line forever. Yup. You can draw a circle with any center and any size. Makes sense. All right angles are equal. Of course. The fifth one, well, the one about parallel lines, that one's a bit more of a beast and has its own wild history, but these 5 rules, they are the foundation. And this is where the magic really happens. This is the final step. With all these raw materials laid out, the definitions, the undefined terms, the axioms, the postulates, Euclid could finally start to build. He used this foundation to construct brand new, provably true statements, which we now call theorems. Take the very first proposition in the Elements, for example. It's a proof showing you how to construct a perfect equilateral triangle. And he does it just by using postulate 3 to draw a couple of circles and axiom 1, that things equal to the same thing are equal idea. With just those tools, he proves with absolute rock-solid certainty that all 3 sides of the triangle have to be equal. It's just beautiful. And from that one simple starting point, this incredible logical chain reaction just kept going. Using only his handful of starting assumptions and the theorems he'd already proven, he went on to deduce, get this, 465 different propositions. He created this vast, interconnected web of knowledge, all from scratch. So what does this all mean? Well, it means something pretty profound, actually. This entire universe of logical certainty, one of the most rigorous, solid fields of human thought, is built on top of a tiny handful of statements that we just accept, without any proof. And that leaves us with one last, kind of provocative thought to chew on. If the beautiful, logical certainty of geometry is built on a foundation of unproven assumptions that we all just agree to accept, then you have to wonder, right? How many other truths out there in our world are built on the exact same kind of foundation?